So our next thing is going to be depolarization. So we've been sitting at about 70 millivolts this whole time, and now we're at the point where we're going to go ahead and start to create an action. So those gated Na channels are open. So remember how those positive ions want to be near negative ions? Well, inside the cell, it's very negative. It's because there's these large proteins that can't leave the cell, and they are embedded inside that cell. So as soon as those gates are open, the sodium definitely wants to come in the cell. So they're flooding inside the cell. And as we get more of these positive charges to come inside the cell, we're going to change that millivolt concentration. And it's going to go from negative 70 to about positive 30 millivolts. So as the cell's getting more positive, we're going to start to create an action. Repolarization is where the gated sodium channels are going to be closed. Those voltage-gated potassium channels are opened. And what happens is potassium diffuses outside the cell. Remember how they want to go from high concentration to low concentration until they get to equilibrium? So calcium is now going to go ahead, potassium is going to go outside the cell and diffuse out. Inside the cell, it becomes a lot more negative, and it returns to about 70 millivolts. And that's where an action is going to take place. Hyperdepolarization is going to be where the voltage gates, the potassium channels, are slowly closed. Excess potassium leaves the cell, and inside the cell it becomes more negative than at resting membrane potential. But we've got to get back to resting membrane potential. And we're going to do that with some energy. The voltage-gated potassium channels close. Sodium-potassium pumps, these are pumps that are going to go ahead and move that sodium and potassium out. And calcium channels are going to be established through that resting membrane potential. And cells are ready for the next stimulus. So if it's something like a twitch, a small little thing, you're going to get one sort of wave and that's it. If it's something like a lot of stimulus, so like something like a huge scratch that you have to do it repeatedly over and over again, that's going to be a lot of these waves back to back to back to back to go ahead and create some energy. So action potential sort of recap. So at number 1, we are at 70 millivolts, that's the rest. The potential energy is waiting to be stimulated, so there's the sodium and potassium on both sides, and we can open those up to create some sort of stimuli. Potassium is diffusing outside the cell in the concentration gradient and through these leaky channels. Number 2 is going to be the gated sodium channels open. Sodium diffuses down a concentration gradient into the cell, and the cell becomes less negative and more positive. Finally, when we're starting to go back to normal, cells will trigger that voltage-gated potassium channels to open. Potassium diffuses outside the cell, and the sodium channels close. So inside the cell becomes more negative. And lastly, hyperpolarization is going to be where the calcium channels will close. So the cell becomes more negative than resting potential. And we have to fix this. And how we fix it is by using these specific pumps to go ahead and make the sodium and potassium pump out. And these pumps, they're done with energy. And for every 3 sodiums they push out, they bring in 2 potassiums inside the cell, and eventually the cell will go back to its resting membrane potential. So the ligand-gated sodium channels start to wave of depolarization. Sodium enters the cell. Currents open nearby voltage-gated sodium channels. And eventually, the voltage-gated sodium channels continue the wave of depolarization, going from one area to the next, to the next, to the next, until that current is gone.